So this is our third notes video. Today we're talking about inelastic collisions. And this is one of two types of collisions that we have, which are inelastic and elastic. For a collision though, is that right? Sorry, hang on. Collision. We know that we have to have a moving object. At least one has to be moving to collide with another. So our initial momentum was 0 in the problems before of our system. It cannot be 0 for collisions. Okay. However, we still have conservation of momentum, so our PI is going to equal PF. Our initial momentum is going to equal our final momentum. And today we're talking about inelastic collisions. So an inelastic collision is when two objects, or I'll just generalize two objects, collide and lose some of their energy to heat, which is not super important right now, but that's where some of their energy goes. So their kinetic energy, which they had from moving, their initial is going to be greater than the kinetic energy they have at the end of the collision. And there's one special case, which is called a perfectly inelastic collision. And that happens when objects stick together. Okay. So a lot of times you'll see or problems will say you have a piece of clay and it comes into and hits, a metal block or something. And then in the end, it will kind of look like this, where they'll be swinging back and forth, but this whole system is kind of stuck together. Now we have a quick example of a inelastic collision. A 20 kilogram medicine ball is thrown with a velocity of 5 meters per second to a motionless child on a skateboard. That's a pretty heavy ball thrown pretty quickly at the child, but we move. The child and skateboard have a combined mass of 60 kg, and we're asked what is the velocity of the system after the child catches the ball. So my initial momentum is going to be 20 kilograms for the ball times its velocity, 5 meters per second, plus our 60 kilogram child skateboard times their velocity, which is 0 meters per second. Clearly this goes away. We have an initial momentum of 100 Newton seconds, or, kilograms meters per second to use the units of the problem. And we want to know our final. So our initial momentum is going to be equal to our final momentum. Now, yeah, don't get confused by this. Our energy is is not going to be the same, but our momentum is. We can use conservation momentum to solve these types of problems. So we have our initial was 100 kilograms meters per second, and that's equal to final velocity of the whole system, which the mass now is going to be 45, or not 45, 20 plus 60 kg, which is always going to be 80 times our final velocity. So that's what we want to find. We can divide 80 over and get that our final velocity is 1.25 meters per second, and it's in the same direction as the ball was thrown. So just to visualize, right? Our medicine ball was thrown at our child on the skateboard, and then after we have our child with the medicine ball caught, moving this way, right? And maybe I shouldn't draw that the same size, moving a little bit slower.